Alrighty, so today we're looking at working with composite 3D shapes. So before we looked at composite 2D shapes where we were just finding the area or the distance around something by putting two shapes together. Now it's the exact same thing, but today we're going to be looking at volumes of 3D shapes. So a composite object is a structure or object made up of several simple objects. Now this is pretty much everything we deal with in everyday life other than things like a soup can or something like that, which is already a cylinder. These are objects like houses or more or less anything that you're talking about. A car can be put together with composite shapes. To determine the volume, we calculate the volume of each part and then just add up the volumes or subtract if anything is removed. So looking at this picture below here, we suppose the shed in the picture has all the measurements indicated, and we are going to add it all up. So there's kind of two methods. The first method is literally adding up the two different types of shapes. So we have a rectangle on the bottom or a cube and then a triangular prism on the top. So if we were to look at the base here, the base is length times width times height. It's 5 times 20 times 10. So we've got 5 on our length, 20 on our width, 10 on our height. None of these actually matter which one is which, okay? Because we're multiplying them all together, so however you put it together, you should get 1,000. Now when we're looking at the top, we're assuming that that 2 is measuring the height here, not the hypotenuse. If it gave you the hypotenuse, then you'd have to make a right angle triangle, say that it's 2.5 on the bottom because we're cutting the 5 in half. So we would cut that in half and it would be 2.5 by 2. We'd have to use a squared plus b squared plus c squared, or a squared plus b squared equals c squared to find the other part. But let's just assume that the 2 is the height. So we're going to do base, which is 5, times height, which is 2, divided by 2. And then we have to multiply it by the depth, which is the depth that it runs, and that's 20 in this case. So we've got base times height times depth divided by 2. Base times height divided by 2 just gives us the area of that front bit. The depth multiplies it through. We get 100. Add them up and you get 1,100 feet cubed. Now there is another way to look at it. If we just found the area of this front piece, and sometimes that's easier and sometimes that's what you need to do, and then multiplied it by the depth, just kind of what we were talking about right here, that will give you the same answer. So in this case, we're going to do the area of the base, which is 50, the area of the top, which is just 5, add them together, and then multiply by the depth, and we get the exact same answer. So when you're going through that, sometimes it'll give you the area of the front of a shape, or like a shape that is squiggly lines or something like that, that you wouldn't be able to use just a typical formula for, and it'll give you the depth. So you would just multiply the area of that shape times the depth to find the volume. Looking at an actual example here, so if we had a poultry trough, so a section of a water trough and a poultry farm is shown. It's got a triangular face, which is what we were just talking about, and then it's really long. It's 120 feet long, but it's only 3 by 5. So what we need to do first is change that 120 feet to inches, so we have a common unit throughout. So we've got 12 times 120 gives us 1,440 inches. Now to find the volume, we're going to do base times height divided by 2 times our depth. Our depth was this number we just found. Okay, base times height is the area of the front divided by 2, and then times depth makes it volume. Pretty much every shape you look at will have something like that. So if you look at a rectangular prism, it's length times width, and it says times height, but really it's times depth. Okay, every time it's times depth. So here we multiply that through, and that's our answer. And the second part of the question says 1 cubic inch is about this many gallons, so 0.00433 gallons. How many liters of water would this trough hold? Now that's important. We need to change our units. So we're going to find out first how many gallons it's going to hold by just multiplying that through. And then 1 gallon is about 3.785 liters. So we need to take our number here and multiply it because we're going from gallons to liters. So we got to multiply to the bigger number. And we find that it's about 177 liters. What you're going to be doing is working on these questions. You're going to find it in cubic centimeters, which is typically the unit that's actually being given. And then you're going to be finding it in ounces. Now remember all of your formulas, so things like a cylinder, your formula is in your textbook. So you'll need to look for the formulas for prisms and cylinders. I'm going to be collecting this. This is going to be your assignment for this unit. And these two are kind of challenge questions. I've given you a hint. You need to find the percent of a cylinder that's present for this question and this question. Okay? This again is your assignment for this unit. It's 8 questions long. You should have a full solution for each of the 8 questions on a separate sheet of paper.